Hello problem solvers. So here is a geometry question. We have a square ABCD with side length 1. We are given that the perimeter of the triangle CEF is 2, and we want to find this angle EAF. So please give it a try. So the first impression of this problem is that the perimeter is 2, and somehow we need to use that. So I tried. So the first approach I tried was a trick approach. So what I did is so essentially just try to break out this. So I let this be y, so this would be 1 minus y, that would be 1 minus x. So the given is that the perimeter x plus y plus this is 2, and I want to find the angle EF. So I will hope that cosine that question mark angle, that would be using cosine law, that would be square of this. As you can see, this square of this is just by Pythagorean, 1 plus square of this, right? So hopefully this will be some expression of x and y. Okay, this some expression of x and y here, and my thought was that maybe I can rely on this relationship to somehow simplify this expression involving x and y, and hopefully it gives me some nice values like 1/2 or square or this, so that we can conclude the angle is 60 or 45, or sorry, 45 is here, 30 or 35. That was my hope, and it gets quite complicated. Okay, of course you have to push the things on the right hand side and square things just to start. It turns out I have to simplify a lot of algebra, and I didn't continue, but I believe it will work. If you try to simplify this, you may get to this expression. Okay, so this is the key relationship. So somehow we need to use this relationship to simplify this expression. But as I said, I didn't continue because just because I'm lazy. But I believe it will work. Because I thought that it's getting quite complicated, so I didn't continue. So before that, I tried to use a geometry approach, and so it turns out the geometry approach works quite simply, and I didn't continue working in that way, but I believe it will work, but it will involve some nasty algebra. Anyway, so let me show you the geometry approach. Just like any other difficult question involving a square, there are several. Okay, I mean, since I begin playing Math Olympiad, there are several square problems that I encounter, and usually the geometry approach involving one technique, and let me tell you, that technique is rotation. That is because square is a regular foregone, right? If you have some experience solving geometry questions, you know that when you solve, let's say, questions about equilateral triangle, sometimes a rotation will work, will give you a nice geometric argument. And in this case here, yes, it gives us a nice geometry argument. So you can have a try. Okay, I didn't say what to rotate. You can have a try before continue. So here is the diagram. What you want to do is to rotate triangle AED so that to here, so that AD coincide with AB and E comes to point G. Okay, please take a moment to stare at the diagram to see why this rotation works. Okay, I hope you have seen it. So the given condition is that parameter CEF is 2. When we rotate this side here, it turns out, you see, this length plus this length is 2, right? This is 1. This is x plus 1 minus x. So altogether, from G to C to CE, that is 2. But we are given x plus y plus EF is 2. So that tells us this length, GF, has the same length as EF. So let me write down. We have GF to here plus FC, which is y, plus CE, which is x, is 2. But we are given x plus y plus EF is also 2. That tells us GF is the same as EF, has the same length. Okay, that is nice, because when we rotate triangle ADE to here, this length is the same as this length. And now we know that this length is the same as this length. And obviously this length in the middle. So that tells us this triangle AEF is congruent to triangle AFG. Well, it doesn't look like it. I didn't draw it nicely, but that's what the AFG side. Okay, because all three sides are the same, right? So what's this angle? So that tells us angle EAF is the same as angle GAF. Okay, but what is this angle? What is this whole angle? This whole angle is 90, right? Because this part is equal to this part. Okay, and this part is 90. So since angle GAE is 90, then they are equal. So they are both equal to 45. That's the solution. So yeah, it's not that often that when you rotate, things just fall out nicely, but in this case it is. Yeah, the insight for this problem, okay, if you want to do a quick reflection, okay, it is, the insight is that whenever you have a difficult question about a regular polygon, try rotation, try rotating things. Okay, very often this works. Okay, rotation is a very effective strategy for a geometry question involving any regular polygon, say equilateral triangle or square or regular pentagon or regular hexagon. Okay, let's give it a difficulty score. I'll say this is around 3 to 4. Let's say 3 out of 9. And the character is Hinata, Naruto's wife. Thank you for watching.